In a recent Chicago Brain Buddies broadcast, we talked about how certain birds can navigate using the Earth's magnetic field. One of the things involved in that navigation is quantum entanglement. Here to talk about that is our buddy, Professor Nick Gross.
You like to talk about the 95% of the universe that we don't understand. The stuff that we do understand, we still don't understand. I make my quantum entangled particles. I take my positron and my electron and I bang them together and I get two photons coming out. Those electrons have spins that have to be in the opposite direction of each other because the spins all have to cancel each other out and they all have to add up.
Conservation of energy.
Right. Those are quantum entangled. Now I do something, I measure the spin of one of those electrons. I know the spin of the other electron. Now I've got two electrons. They originally weren't sensitive to the magnetic field because of the way the bond was. They now get split, and now they are sensitive to the magnetic field. And then when they come back together again, so this bond reforms, it sends out light. The wavelength of light that it sends out depends on the direction of the magnetic field relative to the bird's head. Of course, it's a biological process, right, that we're talking about in terms of this navigation. If you want to do anything in biological processes, in cells, you go find a protein and the protein does the job for you. I think it's really interesting that there's this quantum effect that the birds are taking advantage of in the molecule that can measure the magnetic field.
What are the birds taking advantage of when they're identifying magnetic north?
You've got this complex protein. Most of that protein is inert. It's not the whole protein that's important. It's the little chunk in the middle. It's kind of like the frame of the car, the cab, the lights. That's not all important. It's the motor in the middle that's important. This is the same way with most proteins. It's like this whole framework that the protein has, but then in the middle is this small active group that has this particular bond that's quantum entangled. This isn't light that the bird senses as light right away. The bird sacrifices a little bit of light sensing. That protein absorbs some of the light, changes this bond. So now I've got these two objects that are quantum entangled. Their spins interact with the magnetic field. And it's not just the particles in the protein, it's the bond between two atoms in the protein. So it's the electrons that are quantum entangled.
All of this is happening inside the cryptochrome.
And it's particular to green light. So green light has to be present. So green light comes in, breaks that bond. I now have these two quantumly entangled electrons are now can run independently of each other because of their magnetic properties already respond to the magnetic field.
You get your protein, the green light comes in, breaks the bond.
Right.
Even though the bond is broken between the electrons, they are still entangled because they started off in the same molecular womb together.
Yes,
they're
right.
Still entangled. They're still in my retina.
They start to respond to the magnetic field, and they respond differently.
And they respond because they're to the magnetic field because they are no longer connected to each other. The bond between them has been broken.
When it reforms, you get light back. So that if you put energy in, the energy breaks that bond. But then when the bond reforms, you get that energy back out.
And that energy comes out in the form of a signal that is perceived by the visual system.
It comes out as a photon after they've responded to the magnetic field. Depending on the new orientation, that will tell you the energy of the light that comes back out. The light is just activating this particular protein, this piece of this protein. And that piece of the protein, it's sending another bit of light out as it senses the magnetic field that then the bird sees. So the new light is just coming from the inside the bird.
This protein, which is not a visual protein, not a part of the visual system, hijacks a little bit of the bird's visual perception and gives the bird a signal as to where magnetic north is.
That's my understanding of it.
Frighteningly enough, this might make a little sense.
Okay.
Let me say it again. Here I am with my cryptochrome in my retina. It gets exposed to this green light.
Right.
that breaks the bonds between some of the electrons in this cryptochrome, and
Yep.
and one of them can respond to the magnetic north because
Yeah.
of the electromagnetic properties of electrons. When that bond is reformed, a photon is released into
Yep.
the visual system of the bird that is related to the orientation of magnetic north.
That explanation is as good as an explanation as I can do based on what I've been trying to understand.
I can't tell you how grateful I am that you exist. There is no one I know who is better at explaining this stuff with a good sense of humor than my ace droogie, brother Nicholas Gross. Thank you so much, brother.
Thanks, Aaron. That was great.